Hi, hello, welcome back to i-TUTOR NCERT series. Today, we will be discussing Class 10 Geography NCERT Chapter 5 Minerals and Energy Resources. So, in this chapter, we are going to discuss about the minerals, then form of minerals, that is metallic, non-metallic and energy minerals, then importance of minerals and its occurring state, then conservation of minerals, and also about the energy sources, that is conventional energies and non-conventional energy sources, then the conservation of energy. Okay, so that's a nutshell of this chapter. So let's begin. First, we use different things in our daily life made from metal. The Earth's crust is made up of different minerals embedded in the rocks. Various metals are extracted from these minerals after proper refinement. Minerals are an indispensable part of our lives. Almost everything we use, from a tiny pin to a towering building or a big ship, are all made from minerals. So, we know our day-to-day life has a very much importance in the use of minerals. The railway lines and the tarmac, that is paving of the roads, or implements and machinery too, are made of minerals or made from minerals. Cars, buses, trains, aeroplanes are manufactured from minerals and run on power resources derived from the earth. Even the food that we eat contain minerals. In all stages of development, human beings have used minerals for their livelihood, decorations, festivities, religious and ceremonies rites. Okay, so it's an introduction about this chapter. Now, so let's look what is a mineral. Look at this. Geologists define mineral as a homogeneous, naturally occurring substance with a definable internal structure. So, the geologists define mineral as a homogeneous, naturally occurring substance with a definable internal structure. So, minerals are found in varied forms in nature, ranging from the hardest diamond to the softest talc. So, the hardest diamond, that is also a mineral, and also the softest talc, this is also mineral. So, the minerals are ranging from the hard to soft. Okay, that is from diamond to rock, diamond to talc. So, these are all minerals. Rocks are a combination of homogeneous substance called minerals. So rocks also, we know what is rocks. So these rocks are combination of homogeneous substance called minerals. Some rocks, for instance limestone, consist of a single mineral. Okay, so the limestone consists of a single mineral, but majority of the rock consists of several minerals in varying proportion. Although over 2000 minerals have been identified, only a few are abundantly found in most of the rocks. Okay, so although there are 2000 minerals have been identified, but only a few are abundantly found in most of the rocks. Okay, now a particular mineral that will be formed from a certain combination of elements depends upon the physical and chemical conditions under which the material forms. Okay, so the mineral depend upon the physical as well as chemical condition of the material. This in turn result in a wide range of colors, hardness, crystal forms, luster and density that a particular mineral possesses. Geologists use these properties to classify the minerals. Okay, so the geologists use these properties, that is the color, hardness, crystal forms, luster and density. So these properties to classify the minerals. However, for a general and communal purpose, the minerals can be classified as under. So normally the minerals are classified as metallic minerals, non-metallic minerals and energy minerals. Okay, so minerals are classified as mainly into metallic, then non-metallic, and final one is energy minerals. So what is metallic? The metallic minerals are then further divided into three types, that is ferrous, then non-ferrous, and finally precious. Okay, so the minerals can be classified into metallic, non-metallic and energy minerals. Then the metallic minerals can be classified into ferrous, non-ferrous and precious metals. Okay, so what is ferrous? ferrous means it's contain iron. Okay, so the ferrous contain iron. Okay, so that is called ferrous metals. Now example, iron ore, manganese, nickel, cobalt. So these are example of ferrous metals. The second one is non-ferrous. Okay, that means there is no presence of iron. Example, copper, lead, tin, bauxite, etc. Okay, then final one is precious metals. What are precious metals? We know gold, silver, platinum. These are some of the precious metals. Okay, so the minerals can be classified into metallic, then non-metallic, and energy minerals. Now, metallic minerals can be classified into classified into ferrous, non-ferrous, and precious. Okay, example of ferrous means it contains iron. Example of ferrous metal is iron ore, manganese, nickel, cobalt. Then second one is non-ferrous. Non-ferrous means it does not contain iron. Now example, copper, lead, tin, bauxite. Now precious metal means it's very precious. So example, gold, silver, and platinum. Now second one is non-metallic minerals. Okay, so what is non-metallic minerals? Example, mica, salt, potash, sulfur, granite, limestone, marble, and sandstone. So these are non-metallic minerals. Then finally, energy minerals. Energy minerals means which provide energy, which can be used for an energy source. Coal, petroleum, natural gas. So these are energy minerals. Okay, so that is the general classification of minerals. Now, mode of occurrence of minerals. Where are these minerals found? Okay, so we already discussed about the minerals, but where are these minerals found? Minerals are usually found in ores. Okay, the minerals are usually found in ores. We cannot extract mineral from a pure form, but mostly they are seen as ores. The term ore is used to describe an accumulation of any mineral mixed with other elements. So what is an ore? It's any mineral mixed with other element. Okay, so if a mineral is mixed with other elements, then it is called ore. So that means it's not the purest form of that metal. Okay, the mineral content of the ore must be in sufficient concentration to make it extraction commercially viable. The type of formation or structure in which they are found determines the relative ease with which mineral ores may be mined. This also determines the cost of extraction. It is therefore important for us to understand the main types of formation in which minerals occur. Okay, so now let's discuss about the formation of minerals or forms of minerals. The minerals generally occur in these forms. First one, in igneous and metamorphic rocks, minerals may occur in cracks, crevices, faults, and or joints. Okay, so in igneous and metamorphic rocks, the minerals may occur in the cracks, crevices, faults, or joints. The smaller occurrences are called veins and the larger are called lodes. Okay, so there is two types of occurrence. If the occurrence is small, then it's called vein. Then if it is large, then it is called lodes. In most cases, they are formed when minerals in liquid or molten and gaseous forms are forced upward through cavities towards the Earth's surface. Okay, so most of the time, how this formed? They formed when mineral in liquid or molten, okay, and gaseous forms are forced upward through cavities through the Earth's surface. Now, they cool and solidify as they rise. Okay, so when they rise or when they reach the top of the earth, they suddenly cools or solidify as they rise. Major metallic minerals like tin, copper, zinc, and lead, etc., are obtained from veins and lodes. Okay, so these minerals, that is tin, copper, zinc, lead. So these are obtained from the veins and lodes. Okay. Now, second one is, so here we discussed about the igneous and metamorphic rocks. Now, in sedimentary rocks, a number of minerals occur in beds or layers. Okay, so in igneous and metamorphic rocks, what it's called veins and lodes. But in sedimentary rocks, the minerals occur in beds or layers. They have been formed as a result of deposition, accumulation and concentration in horizontal strata. Okay, so they have been a result of deposition, accumulation and concentration in a horizontal strata. Coal and some forms of iron ore have been concentrated as a result of long period under great heat and pressure. Another group of sedimentary minerals including gypsum, potash salt and sodium salt. These are formed as a result of evaporation, especially in arid regions. Okay, so these are mainly found in the sedimentary rock system. Next one. Another mode of formation involves the decomposition of surface rocks and the removal of soluble constituents, leaving a residual mass of weathered materials containing ores. Now, bauxite is formed in this way. Okay, so next one is the formation involving the decomposition of surface rocks and the removal of soluble constituents, leaving a residual mass of weathered material containing ores. Okay, so it leave a residual mass of weathered material and which contain ores. So, for example, bauxite. Bauxite is extracted from this method. Now, next one is certain minerals may occur as alluvial deposits in sands of valley floors and the base of hills. These deposits are called placer deposits. Okay, so in some cases, certain minerals may occur as alluvial deposits in sands of valley floor and the base of hills. So they are called placer deposits and generally contain minerals which are not corroded by water. Okay, so in this case, the minerals are not corroded by water. Gold, silver, tin and platinum are most important among such minerals. Okay, so the gold, silver, tin and platinum. Okay, so they are some of the example. Now, next one is the ocean water contains vast quantities of minerals, but most of these are too widely diffused to be economic significance. However, common salt, magnesium and bromine are largely derived from ocean water. The ocean beds too are rich in manganese nodules. Okay, so now we are discussing about the ocean water. We know the ocean water have a vast quantities of minerals, but most of these are too widely diffused to be economic significance. And mostly we know the common salt, magnesium and bromine. These are largely derived from ocean water because these are very easy to access and very easy to collect. The ocean beds too are rich in manganese nodules. Okay. Now, most of the minerals in India are nationalized and their extraction is possible only after obtaining due permission from the government. Okay, so most of the minerals in India are nationalized and the extraction is possible only after the obtaining due permission from the government. But in most of the tribal areas of the northeast India, the minerals are owned by individual or community. Okay, so in most of the northeast India, the minerals are owned by individuals or the communities. In Meghalaya, there are large deposits of coal, iron ore, limestone and dolomite, etc. Coal mining in Jowai and Chirapunji is done by family member in the form of a long narrow tunnel known as rat hole mining. Okay, so the coal mining in Jowai and Chirapunji, it is done by the family member in a form of a long narrow tunnel. So this is known as rat hole mining. Okay, so this system is known as rat hole mining. Now, moving forward, India is fortunate to have fairly rich and varied mineral resources. We know India is a very rich in mineral resource. However, these are unevenly distributed. Broadly speaking, peninsular rocks contain most of the reserves of coal, metallic minerals, mica and many other non-metallic minerals. Now, sedimentary rocks on the western and eastern flanks of the peninsula in Gujarat and Assam have most of the petroleum deposits. Rajasthan, with the rock system of the peninsula, has reserves of many non-ferrous minerals. The vast alluvial plains of the North India are almost divided for economic minerals. These variations exist largely because of the difference in the geological structure, process and time involved in the formation of minerals. Okay, so these variations are mainly because of the geological structure, the process of the formation of minerals, and time involved in the formation of minerals. Always remember that the concentration of mineral in ore, the ease of extraction, and the closeness to the market play an important role in affecting the economic viability of a reserve. Okay, so these are some of the factors which affect the economic viability of these minerals. First one is concentration of minerals in the ore, then the ease of extraction and closeness to the market. Closeness to the market. Okay, so these play an important role in the economic viability of the reserve. Thus, to meet the demand, a choice has to be made between a number of possible options. When this is done, a mineral deposit or reserve turns into a mine. Okay, so when it is done, when these above factors are done, then a mineral deposit or reserve turns into a mine. Okay, mine means the place where we extract the minerals. Now, next let's discuss about ferrous minerals. Okay, so ferrous minerals account for about 3/4 of the total value of production of metallic minerals. Okay, so we classified metallic minerals into 3 types: ferrous, non-ferrous, and energy. Okay, we classify minerals into 3 types. Look at this picture. Mainly metallic, non-metallic, and energy minerals. Now we classify metallic minerals into ferrous, non-ferrous, and precious. So here first one is ferrous. It accounts about 3/4 of the total value of the production of metallic minerals. Okay, they provide a strong base for the development of metallurgical industries. India exports substantial quantities of ferrous minerals after meeting her internal needs. Okay, so we India export a substantial quantities of ferrous minerals. Now, iron ore. Iron ore is the basic mineral and the backbone of industrial development. So, iron ore is the backbone of industrial development. India is endowed with fairly abundant resources of iron ore. India is rich in good quality iron ores. Magnetite is finest iron ore with a very high content of iron up to 70%. Okay, so the magnetite, this is a finest iron ore which contains iron up to 70%. It has excellent magnetic qualities, especially valuable in the electrical industry. So the magnetite is mainly used in the electrical industry. Okay, so magnetite, it's very finest iron ore which contains 70% of the iron, and it has an excellent quality, that is magnetic quality. Now, so they are mainly used in the electrical industry. Okay, so that is about the magnetite. Magnetite is a finest iron ore. Next one is hematite ore. Is the most important industrial iron ore in terms of quantity used. So next one is, first one is magnetite. Now second one is hematite. This is important because by the quantity. But has a slightly lower iron content than magnetite. Okay, but the iron content is lower. Okay, lower iron content. So that is the difference between magnetite and hematite. Okay, in magnetite there is 70% of iron content, but in hematite there is 50 to 60% iron content. Okay. Now, next let's discuss about the major iron ore belts in India. First one, Orissa Jharkhand belt. In Orissa, high grade hematite ore is found in Badambapahar mines in Mayurbhanj. Okay, so in Odisha, the high grade hematite. Okay, we discussed about the two types of iron ore, that is first one magnetite and hematite. In Odisha we can find the hematite. Okay, hematite ore found in the Bedampahar mines in Mayurbhanj and Kendujar district. Okay, so next in the adjoining Singhbhum district of Jharkhand, hematite iron ore is mined in Goa and Noamundi. Okay, so that is the Orissa Jharkhand belt. Next one is Durg Bastar Chandrapur belt. So that lies in Chhattisgarh and Maharashtra. Okay, so this Durg Bastar Chandrapur belt lies in the Chhattisgarh, Maharashtra. Very high grade hematite are found in the famous Bailadila range of hills in the Bastar district of Chhattisgarh. The range of hills comprises of 14 deposits of super high grade hematite. Okay, so it contains super high grade hematite. It has the best physical properties needed for steel making. Iron ore from these mines is exported to Japan and South Korea via Visakhapatnam port. Okay, so iron from this place this mines is exported to Japan and South Korea via the Visakhapatnam port. That's in Andhra Pradesh. Next, Bellary, Chitradurga, Chikmagalur, Tumkur belt in Karnataka. So next one is Bellary, Chitradurga, Chikmagalur and Tumkur belt, that is in Karnataka, has large reserve of iron ore. The Kudremukh mines located in the western ghats of Karnataka are a 100% export unit. Kudremukh deposits are known to be one of the largest in the world. Okay, so the Kudremukh iron deposits, these are known as these are one of the world's largest iron deposit place. The ore is transported as slurry through a pipeline to a port near Mangalore. Okay, so this ore is transported as a slurry through a pipeline to a port of Mangalore. So what is Kudremukh? Look at this. Kudre in Kannada means horse. The highest peak in the western ghats of Karnataka resembles the face of a horse. The Bailadila hills look like the hump of an ox and hence the name. Okay, so that is why it is known as Kudre. Okay, Kudremukh. Okay, because in Kannada Kudre means horse. Okay, and Mukh means face. So that's why it resembles the face of a horse. So that is known as Kudremukh. Next one is Maharashtra Goa belt. It includes the state of Goa and Ratnagiri district of Maharashtra. Though the ores are not very high quality, yet they are efficiently exploited. Iron ore is exported through Marmagao port. Okay, so that's about the iron ore. So we discussed about iron ore, and mainly it has two important ores. First one is magnetite, then hematite. Magnetite has 70% of iron and it's a good quality. Then it is magnetic quality. It has a magnetic quality and it's also used in the electrical industry. The second one is hematite. It is important in the quantity wise and its lower iron content, that is 50 to 60%. Then the major iron ore belts in India. Next one is manganese. Manganese is mainly used in the manufacturing of steel and ferromanganese alloy. Nearly 10 kg of manganese is required to manufacture 1 ton of steel. It is also used in manufacturing bleaching powder, insecticides and paints. Okay, so these are some other uses of manganese, that is manufacturing bleaching powder, insecticides and paints. Orissa is the largest producer of magnetite ore in India. Okay, so Orissa is the largest producer of magnetite ore in India. It accounts for 1/3 of the country's total production. Okay, in 2000 and 2001. Okay, so in 2000 and 2001, it accounts for the 1/3 of country's total production. Now, non-ferrous minerals. So now we discussed about the ferrous minerals. Next one is non-ferrous. India's reserve and production of non-ferrous minerals is very satisfactory. Sorry, it's not very satisfactory. Okay, so the non-ferrous minerals production is not very satisfactory. However, these minerals, which included copper, bauxite, lead, zinc, and gold play a vital role in number of metallurgical, engineering, and electronic industries. Okay. Now let's discuss about the copper and bauxite. Here gold is a precious metal and now copper. India is critically deficient in the reserve and production of copper. Okay, so India is critically deficient in the reserve and production of copper. Being malleable, ductile, and a good conductor, copper is mainly used in electrical cables, electronics, and chemical industries. So the copper is mainly used in the electrical cable, electronic industries, and chemical industries. The Balaghat mines in Madhya Pradesh produce 52% of India's copper. The Simham district of Jharkhand is also a leading producer of copper. The Khetri mine in Rajasthan are also famous. Okay, so these are some of the important copper mining places. First one, the Balaghat mines in Madhya Pradesh, then Simham district of Jharkhand, then Khetri mines of Rajasthan. Okay, so Madhya Pradesh, Jharkhand, and Rajasthan. These are some important states which produces copper. Next one is bauxite. Though several ores contain aluminium, it is from bauxite. Okay, a clay-like substance that alumina and later aluminium is obtained. Okay, so what is bauxite? It is several ores contain aluminium and it's like a bauxite. It's from bauxite. A clay-like substance. It's a clay-like substance and alumina and later aluminium is obtained. Bauxite deposits are formed by the decomposition of a wide variety of rocks rich in aluminium silicates. Okay, so it is formed by the decomposition of a wide variety of rocks and which are rich in aluminium silicates. Aluminium is an important metal because it combines the strength of metals such as iron with extreme lightness and also with good conductivity and great malleability. India's bauxite deposits are mainly found in Amarkantak Plateau, Michael Hills, and the plateau region of Bilaspur Kandi. Okay, Bilaspur Katni. So the bauxite deposits are mainly found in Amarkantak Plateau, Michael Hills, and the plateau region of Bilaspur Katni. Orissa is the largest bauxite producer state in India with 45% of the country's total production in 2000 and 2001. Okay. Now, Panj Patmali deposits in Koramput district are the most important bauxite deposits in the state. Okay, so that's about the bauxite. Okay. Next, non-metallic minerals. Mica is a mineral made up of a series of plates or leaves. It splits easily into thin sheets. These sheets can be so thin that thousands can be layered into a mica sheets of a few centimeters high. Mica can be clear, black, green, red, yellow, or brown. Due to its excellent dielectric strength, low power loss factor, insulating properties, and resistance to high voltage, mica is one of the most indispensable minerals used in the electric and electronic industries. So, the mica can be used in the electric as well as electronic industries. Mica deposits are found in the northern edge of the Chota Nagpur Plateau, Koderma Hazaribagh belt of Jharkhand, and Hazaribagh belt of Jharkhand is the leading producer. Okay, so it can be mainly found in the northern edge of Chota Nagpur Plateau. Then Koderma Hazaribagh belt. This is found in Jharkhand. It is the leading producer of non-metallic minerals. Now, in Rajasthan, the major mica producing areas is around Ajmer. Nallur mica belt in Andhra Pradesh is also an important producer of the country. Okay, so we discussed about mica. Then mica is a mineral made up of series of plates or leaves, and it's mainly used in the electronic industries. Then its deposit is found in the northern edge of Chota Nagpur Plateau. Then Koderma Hazaribagh belt, that is in the Jharkhand. It's a leading producer. Then in Rajasthan, the major mica producing area is around Ajmer. Nallur mica belt of Andhra Pradesh is also an important producer in the country. Now, rock minerals. Limestone is found in association with the rocks composed of calcium carbonates or calcium and magnesium carbonates. It is found in sedimentary rocks of most geological formation. Limestone is the basic raw material for the cement industry and essential for smelting iron ore in the blast furnace. Okay, so limestone. What is limestone? It's mainly found in association with rocks composed of calcium carbonates or calcium and magnesium carbonates, and is mainly found in the sedimentary rocks of most of the geological formation. Then it is the basic raw material for the cement industry and essential for smelting iron ore in the blast furnace. Okay, next one is conservation of minerals. We all appreciate that strong dependence of industry and agriculture upon mineral deposits and the substance manufactured from them. The total volume of workable mineral deposits is an insignificant fraction, that is 1% of Earth's crust. We are rapidly consuming mineral resources that require millions of years to be created and concentrated. The geological process of minerals formation are so slow that the rates of replenishment are infinitely small in comparison to the present rate of consumption. Okay, so the replenishment are indefinitely small in comparison of the consumption. Okay, so the consumption is high. Consumption is high than the replenishment. So finally, so it leads to what? The loss of minerals, or the or we cannot use minerals in the future. Okay, it leads to the loss of minerals. Okay, lead to the minerals problem. Now, mineral resources are therefore finite and non-renewable. Okay, so these minerals are non-renewable. Okay, rich mineral deposits are our country's extremely valuable but short-lived possession. Continued extraction of ores lead to increasing cost of mineral extraction comes from greater depth along with decrease in quality. Okay, so this lead to the quality decreases. A concerted efforts has been made in order to use our mineral resources in a planned and sustainable manner. Improved technological needs to be constantly evolved to allow use of low-grade ores at low cost. Recycling of metals using scrap metals and other substitutes are steps in conserving our mineral resources for the future. Okay, so we should conserve our minerals for the future as well as. Okay, that is called sustainable. We should focus on the sustainable development goals by conserving the nature and minerals also. Okay, if our consumption increases and the replenishment decreases, it leads to the mineral losses. Okay, or mineral deficiency. Okay, the deficiency of mineral, it leads to the deficiency of mineral. It may affect our future generation. Now, energy resources. Energy is required for all activities. It is needed to cook, to provide a light and heat, to propel vehicle, and to drive machinery in industries. Energy can be generated from fuel minerals like coal, petroleum, natural gas, uranium, and from electricity. Energy resources can be classified as conventional and non-conventional sources. Conventional sources include firewood, cattle dung, cake, coal, petroleum, natural gas, and electricity. That is both hydel and thermal. Non-conventional resources including solar, wind, tidal, geothermal, biogas, and atomic energy. Now, firewood and cattle dung cake are most common in rural India. According to one estimate, more than 70% energy requirement in rural household is met by these two, that is by by firewood and cattle dung cake. Continuation of this is increasingly becoming difficult due to the decreasing forest area. Moreover, using dung cake too is being discouraged because it consumes most valuable manure which could be used in agriculture. Okay, so if you use dung cake as an energy source, then what happened? It may lose the good manure for the agriculture, because the dung cake is a good manure for the agriculture. It's a valuable manure for the agriculture. So if you use this dung cake as a energy resources, then we lose the agriculture. Now, conventional sources of energy. First one is coal. In India, coal is the most abundantly available fossil fuel. Okay, so in India, coal is the most abundantly available fossil fuel. It provides a substantial part of the nation's energy need. It is used for power generation, to supply energy to industry as well as for domestic needs. India is highly dependent on coal for meeting its commercial energy requirements. Coal is formed due to the compression of plant material over millions of years. Coal, therefore, is found in a variety of forms depending on the degree of compression and the depth and the time of burial. Decaying plants in the swamps produce peat, which has a low carbon and high moisture content and low heating capacity. Lignite is low-grade brown coal, which is soft with high moisture content. The principal lignite reserve are the Neyveli in Tamil Nadu are used for generation of electricity. Okay, so the lignite reserves in Neyveli in Tamil Nadu, that is used for the generation of electricity. Coal that has been buried deep and subjected to increased temperature is bituminous coal. Okay, so next one is bituminous coal. First one is lignite reserve, lignite. Then here next one is bituminous coal. It is the most popular coal in commercial use. Metallurgically, coal is high-grade bituminous coal, which has a special value for smelting iron in blast furnaces. Okay, so which is used in the blast furnace. Anthracite is a highest quality hard coal. Okay, so we discussed about three types of coal. First one lignite, then bituminous, and here now anthracite. Anthracite is the highest quality hard coal. In India, coal occurs in the rock series of two main geological ages, named the Gondwana, that is a little over 200 million years in age, and in tertiary deposits which are only about 55 million years old. The major resources of Gondwana coal, which are metallurgical coal, are located in the Damodar Valley, West Bengal Jharkhand region, then Jharia, Raniganj, Bokaro are important coal fields. Okay, so these are some important coal fields in India. The Godavari, Mahanadi, Sun and Vardha valleys also contain coal deposits. Tertiary coals occur in the northeastern states of Meghalaya, Assam, Arunachal Pradesh and Nagaland. Remember, coal is a bulky material which loses weight on use and is reduced to ash. Hence, heavy industries and thermal power stations are located on or near the coal fields. Okay. Now next one, petroleum. Okay, so we know the importance of petroleum today. It is very precious one. Petroleum or mineral oil is the next major source of energy source in India after coal. It provides fuel for heat and lighting, lubricants for machinery and raw materials for a number of manufacturing industries. Petroleum refineries act as the nodal industry for synthetic textile, fertilizer and numerous chemical industries. Most of the petroleum occurrences in India are associated with anticlines and fault straps in the rocks formation of the Tertiary age. In regions of folding, anticlines or domains, it occurs where oil is trapped in the crust of the hold. The oil-bearing layer is a porous limestone or sandstone through which oil may flow. The oil is prevented from rising or sinking by intervening non-porous layers. Petroleum is also found in the fault strap between porous and non-porous rocks. Gas, being lighter, usually occur above the oil. About 63% of India's petroleum production is from Mumbai High, okay, and 18% from Gujarat and 16% from Assam. Okay, so mainly 63% of petroleum from Mumbai High. 63% from Mumbai High. Then 18% from Gujarat and 16% from Assam. From the map, locate the 3 major offshore fields of Western India. Okay, so this is an assignment for you. Locate the 3 major offshore fields of Western India. Now, Ankaleshwar is the most important field of Gujarat. Okay, so Ankaleshwar, that's the most important field in the Gujarat. Okay, you can find this place in the map. Assam is the oldest oil producing state in India. Digboi, Nahar Katia and Moran Hujri Jan are important oil fields in the state. Okay, so this is some important oil state in the state of Assam. Okay, oil field in the state of Assam. So that's all the petroleum. Next one is natural gas. Natural gas is an important clean energy resource found in association with or without petroleum. It is used as a source of energy as well as an industrial raw material in the petrochemical industry. Now, natural gas is considered an environment friendly fuel. Okay, it is considered as an environment friendly fuel because of low carbon dioxide emission and is therefore the fuel for the present century. Okay, so the natural gas is considered as the fuel for the present century because it's very clean. Large reserves of natural gas has been discovered in the Krishna Godavari basin. Along the west coast of the reserves of Mumbai High and allied fields are supplemented by finds in the Gulf of Cambay. Andaman and Nicobar Islands are also important areas having large reserves of natural gases. The 1,700 km long Hazira Vijaypur and Jagadishpur cross-country gas pipeline links Mumbai High and Basin with the fertilizer, power and industrial complexes in western and northern India. This artery has provided an impetus to India's gas production. The power and fertilizer industries are the key uses of natural gas. Use of compressed natural gas, that is CNG, for vehicles to replace liquid fuel is gaining wide popularity in the country. Okay, so the use of CNG for the vehicles to replace liquid fuel, okay, that is gaining wide popularity in the country because today we are moving to the green energy. Now next one is electricity. Electricity has such a wide range of applications in today's world that its per capita consumption is considered as an index of development. Electricity is generated mainly in 2 ways: by running water, which drives hydro turbines to generate hydroelectricity, and by burning other fuels such as coal, petroleum and natural gas to drive turbines to produce thermal power. Okay, so there is hydroelectricity and thermal electricity. Once generated electricity is exactly the same. Okay, so if you if you generate the electricity through a thermal power, it's also do the same process by generating the electricity like the hydroelectricity. Hydroelectricity is generating by fast flowing water, which is a renewable resource. India has a number of multi-purpose projects like the Bagranangal, Damodar Valley Corporation and the Kopli Hydel project. Okay, so these are some of the examples for hydroelectric power energy. Next, thermal electricity is generated by using coal, petroleum and natural gas. The thermal power station uses non-renewable fossil fuels for generating energy. Okay, so they uses non-renewable fossil fuels for generating electricity. There are over 310 thermal power plants in India. Now, nuclear or atomic energy. It's obtained by altering the structures of atoms. When such an alteration is made, much energy is released in the form of heat and this is used to generate electric power. The uranium and thorium which are available in Jharkhand and the Aravalli ranges of Rajasthan are used for generating atomic or nuclear power. The monazite sands of Kerala is also rich in thorium. Okay, so next one is nuclear or the atomic energy. It is obtained by the use of atoms. Okay, so we alter the structure of atoms for obtaining the atomic energy, and this gave a much more energy, and it's released the form of heat, and this generate electric power. Okay, next one is non-conventional source of energy. The growing consumption of energy has resulted in the country becoming increasingly dependent on fossil fuels such as coal, oil, and gas. Rising prices of oil and gas and their potential shortage have raised uncertainties about the security of energy supply in future, which in turn has a serious repercussion on the growth of the national economy. Moreover, increasing use of fossil fuels also causes serious environmental problems. Hence, there is a pressing need to use renewable energy sources like solar energy, wind, tide, biomass, and energy from waste materials. Okay, so this is another way or alternative method to use these things because these are renewable source. Okay, and they can available at any time. These are called non-conventional energy sources. Okay, so these things, that is the solar energy, wind, tide, biomass, and energy from the waste materials, these are called non-conventional energy. India is blessed with an abundance of sunlight, water, wind, and biomass. It has the largest programs for the development of these renewable energy resources also. So let's discuss about solar energy now. We know India is a tropical country. It has enormous possibilities of tapping solar energy. Photovoltaic technology converts sunlight directly into electricity. Okay, so what is the technology? That is called a photovoltaic technology. Okay, so this photovoltaic technology converts sunlight into the electricity. Okay, sunlight, photovoltaic technology. Photovoltaic technology directly into electricity. Okay. Solar energy is fast becoming popular in rural and remote areas. The largest solar plant in India is located in the Madhapur near Bhuj, where solar energy is used to sterilize milk cans. It is expected that use of solar energy will be able to minimize the dependence of a rural household on firewoods and dung cakes, which in turn will contribute to the environmental conservation and adequate supply for the manure in agriculture. Okay, so the use of solar energy may decrease the decrease the use of firewood and dung cakes in the rural areas. Okay, and which is very adequate or which is very benefit for the agriculture sector. Okay, so that's about solar energy. Next one is wind power. India now ranks as wind superpower in the world. The largest wind farm clusters is located in the Tamil Nadu from Nagarkoil to Madurai. Apart from these, Andhra Pradesh, Karnataka, Gujarat, Kerala, Maharashtra, and Lakshadweep have important wind farms. Nagarkoil and Jaisalmer are well known for the effective use of wind energy in the country. Okay, so these are some two important places which are known for the effective use of wind energy. That is Nagarkoil in Tamil Nadu and Jaisalmer in the Rajasthan. Next one is biogas. Shrubs, farm waste, animal and human waste are used to produce biogas for domestic consumption in rural areas. Decomposition of organic matter yields gas, which are higher thermal efficiency in comparison to kerosene, dung cake, and charcoal. Biogas plants are set up at municipal, cooperative, and individual levels. The plants using cattle dung are known as gobar gas plants. Okay, so the plants using cattle dung, these are known as gobar gas plant. These provide twin benefit to farmers from the in the form of energy and improved quality of manure. Okay, so these gobar gas plants give two types of benefits. First one is it can be used as an energy source, and second one is it is a good manure, good quality manure. Biogas is by far the most efficient use of cattle dung. It improves the quality of manure and also prevents the loss of trees and manure due to burning of fuel wood and cow dung cakes. Okay, so that is the importance of biogas. Next one is tidal energy. Oceanic tides can be used to generate electricity. Floodgate dams are built across inlets. During high tide, water flows into the inlet and gets trapped when the gate is closed. After the tide falls outside the floodgate, The water retained by the floodgate flows back to the sea via a pipeline that carries it through a power generating turbine. So in India, the Gulf of Kutch provide ideal conditions for utilizing tidal energy. A 900 megawatt tidal energy power plant is set up in the National Hydro Power Corporation. Okay, so in Gulf of Kutch, there is a 900 megawatt tidal energy power plant is set up, okay, by the National Hydropower Corporation. Next, geothermal energy. Geothermal energy refers to the heat and electricity produced by using the heat from the interior of the earth. Geothermal energy exists because the earth grows progressively hotter with increasing depth. When the geothermal gradient is high, high temperatures are found in the shallow depths. Groundwater in such areas absorb heat and from the rocks are become hot. It is so hot when it rises to the earth's surface, it turns into steam. Okay, so when it rises to the earth's surface, it turns into steam. This steam is used to drive turbines and generate electricity. There are several hundreds hot springs in India which could be used to generate electricity. 2 experimental projects have been set up in India to harness geothermal energy. One is located in the Parvati Valley near Manigaran in Himachal Pradesh and the other is located in the Pugha Valley, Ladakh. Okay, so these are 2 experimental projects places, okay, for the harness of geothermal energy. Now let's discuss about the conservation of energy resources. Energy is a basic requirement for economic development. Every sector of national economy, that is agriculture, industry, transport, commercial and domestic, needs input of energy. The economic development plans implemented since independence necessarily require increasing amount of energy to remain operational. As a result, consumption of energy in all forms has been steadily rising all over the country. In this background, there is an urgent need to develop a sustainable path of energy development. Promotion of energy conservation and increased use of renewable energy sources are the twin planks of sustainable energy. India is presently one of the least energy efficient countries in the world. We have to adopt a cautious approach for the judicious use of our limited energy resources. For example, as concerned citizens, we can do our bit by using public transport system instead of individual vehicle. Okay, so these are some of the methods to limit the energy resources. Now, switching off electricity when not in use, using power saving devices and use non-conventional source of energy. So these are some of the methods to reduce the use of energy. Okay, for example, first one, using public transport system, then switching off electricity when not in use, using power saving devices and using non-conventional source of energy, and these are some of the methods by saving energy. After all, the energy saved is energy produced. Okay, the energy saved, how much energy we saved, that is the energy we produced. Okay, so that's about the chapter. If you have any doubts, you can comment below. For more videos, do like, share, subscribe.